Hello and welcome back. Today we're going to jump into the second of our hands-on videos, but really the first part of our case study where we actually sit down and start to analyze this defect data. And as we're prepping for that, I want to make sure that we're all kind of starting from the same place. So if you followed along with the previous video, you should have a directory on your system at a path similar to documents/Suture quality analysis that contains a few files within it. We should have the raw data that was downloaded in preparation for this exercise, and then we should have the R markdown file that we were processing together last time, as well as an HTML file that represents sort of the compiled or rendered version of that R markdown report. Now, to start, we're actually going to reuse this markdown file. So let's start by navigating to the appropriate directory. Mine is, again, just my root directory for the system, documents, and then Suture quality analysis. Once I'm there, I'm going to double click on my R markdown file, and this is actually going to open up R for me. So we'll let R kind of spin up, or I guess I should say R Studio. And you'll notice that in this particular instance, R remembers a few things about what I was looking at previously. So it's opening up an extra window for me. That may or may not happen for you. It's really not a huge deal either way. Just do whatever is necessary to get back to this setup where we have the script that we were writing in terms of that R markdown file. And really just that should put us in a position where we have, access to everything that we need to get going. Now, during our last video, I had you create that folder, our project folder, and put some key files in it. And then we were using this set working directory command in order to tell RStudio where to look. And that can be an effective way to manage your workflow. There are some disadvantages to using the set working directory command. Number one is that if we're truly trying to build a report that is reproducible and we hand this file to another member on our team or another person in a different department, they're going to run into a problem pretty immediately because they do not have a user file titled Alex Rose or Alex_Rose in this case. And so that's going to put them at a disadvantage. They're going to have to come in and manually modify this script before they can get it to run. Fortunately, our friends at RStudio do provide a pretty clean way to deal with this, and that's through an R project. Now, I think the easiest way to set up an R project is actually to locate the R project button in the top right-hand corner of the RStudio window. We can see it right here. And you'll notice that it's got this little icon signifying that it's a project, and then it says project : and normally it would load our project title there. However, you'll notice that there isn't any, so we get this none printed out instead. We're going to create a project that will help us manage this analysis in a friendlier way and put us in a position where we can use what are called relative file paths. That basically means that this R project is going to know that it lives in the Suture quality analysis folder. And so instead of typing out this full file path, we can literally just say, go down one folder into raw data and collect this item. Or if we don't have any sort of nested folders, look for this file in the folder that is currently our working directory and our project root folder. Those two can be the exact same thing. So to start, let's go ahead and click on that button. You'll notice that we're given a few options here. This can be really helpful because once we load and create a project, we can actually close it and then open it up again using the same button. But because this is our first time, we're just going to click on New Project, and it's going to present us with this user interface, asking us what source we want to use for the project. And we have three options. One is a new directory, and you'll remember that directory is just another name for a folder on your computer. So this is saying, hey, would you like to start a project in a brand new directory? That doesn't apply to us because we already set up a directory when we started downloading our files. We also see this third option that's called version control, and it says, would you like to check out a project from a version control repository? Version control repositories are something like a Git-based system, so GitLab or GitHub. There's a few other different ones out there. Those are probably the two most popular. While this is really powerful, it's not something that really applies to us either. So we're going to choose option number 2, existing directory, and you'll notice that it's telling us what it is going to do. It is going to associate a project with an existing working directory. So clicking on that, it is now asking us to input that file path. Now, mine is already aware of that being the working directory, but you will very likely have something that looks a little bit more like this with nothing in it at all. And so if that is the case, that's no problem at all. We just need to hit browse, and we would go to our documents folder and select our project folder. I'm going to double click there, and then I'm going to hit open, and you'll notice that it's got the same file path as before. It didn't update for me, but it should have updated for you because you won't already have that value there. And once we're there, we're just going to hit create project. We're going to give it a little bit of time to spin up. You'll notice it'll restart, and it has now created a project for our Suture quality analysis that is pretty much independent of the other folders on our computer. And you'll also notice that in this files pane, it's automatically taken us to the Suture quality analysis folder, and we can see the files that we were working with last time. Now, if you'll remember from our last video, this is a window into our file system. So if I click over into the file system, this is the exact same view. You'll notice that when we created that project, a few things happened. You can even see these based off of our creation dates as well. When we created that project, we have this Suture quality analysis.rproj file, an R project file that was created. And we also had these 2 other files created. Now, my system is set up to show me what are called hidden items. You may or may not see this .r project user. It's not a big deal either way, but this is demonstrating to us that a change has taken place. So if I come back to RStudio, you'll notice that, again, we're working within this kind of defined project already, and I can do some things right off the bat. For instance, if I want to open up my RMD file, I can just click it, and it's going to open up that particular script for me. If I wanted to open up some other files, if I had a couple different scripts in the same folder, I could do so with just the click of a button. So this is really a great way to simplify our workflow and kind of create self-contained analyses. So I sort of mentioned that we don't really need this working directory code chunk anymore. So we're just going to go ahead and delete that from our folder, or rather from our script. And we're going to go ahead and look at some of the other things that we have in here. Now, I don't need to install the tidyverse again. I've already got that taken care of. I will need to load it. And we can see that we have a few things left over from when we were testing out the basic functionality of R. So I'm actually going to go ahead and delete those as well. Now, I just have a very bare bones RMD script that I'm going to go ahead and run. And in so doing, I should load this tidyverse package. So I'm going to come over here to run, and I'm going to select run all. That's going to take a moment to process, and once it does, it'll print out some output for us. This should all look very familiar based off of our previous session. Now, there's a couple other ways I could have done this if I wanted to. I could have clicked each of the run chunk buttons like we did last time, or I could have gone to the very last code chunk and hit run all chunks above and then run this code chunk as well. There's not necessarily anything wrong with that, but the first time I'm loading up a script, R will very likely have no recollection of what was done previously, unless you configure your settings to sort of preserve the objects that you create through your analysis. And even if you do set your settings in such a way that it's going to preserve some of the objects that are created, it's good practice the first time you open up a script to run all of the chunks in it and see the current state of your analysis. So again, I do that by coming up to this run button, and I'm just going to come all the way down to run all. You'll notice it also provides a keyboard shortcut for us if we want to do that without using the menus next time. So we're set up and we're kind of ready to go. Now, the first thing that we need to do is bring into our environment the data that we were using, or rather the data that we captured as part of our defect analysis. That's the CSV file that you downloaded. Now, there's a few different ways to do this, just like everything that we've talked about. One way to do this is to click on the suture underscore defect underscore data.csv file in the Files tab of this bottom right-hand pane. And when I do that, it brings up a list. I can either view the file directly or I can import the data set. I'm going to click Import this data set, and you'll notice that it prompts us with quite a few helpful things. Right off the bat, it's showing us the file path where that data set exists. If I wanted to, I could type in a new path and have it load that file as well. It also gives us a quick preview of what data are included in this file. You'll notice that there's a few little graphical wonks, but that's not really a big deal. And then you'll notice down at the bottom that it actually gives us a code preview as well. And this starts to show us the basic structure behind loading code into our R environment. Now, this is using a package called Reader. Reader is, however, included in the tidyverse. The tidyverse is a collection of packages, so we don't actually need this first line of code. But if we wanted to do this same operation in code, I could highlight this line of code. I'm going to use Control-C to copy that line of code, and then I'm going to cancel this operation, and I'm going to use code to read in this file. Now, you might be asking, why not just click the import button and proceed as necessary? That makes some sense, but if you recall, our purpose here is to really script out every step of the process so that we can recreate this analysis with the click of a button. And if I do anything in the user interface, I've not accounted for it in my automation script. So for that very reason, rather than clicking the import button, I'm going to highlight this line of code. I'm going to copy it. I'm going to cancel this. And then I'm going to come up to line 18 in our markdown file. It might be a slightly different line for you based on how some things are structured, but basically a fresh line. And I'm going to use the same keyboard shortcut that I used previously to insert a code chunk. As a refresher, that's Control, Alt, and I. Now that I've done that, I'm just going to paste in that code section, and you'll notice that this is exactly the same kind of code as before, and it is automatically suggesting a name for us based off of the name of the file. There's nothing wrong with this name, but I like to use slightly different naming conventions when I'm titling objects that I'm going to use. So I'm actually going to call this Defect. And I'm going to put a period and put in a couple letters that tell me what kind of object this is. And I'm going to put in a DF there, and that stands for a data frame. Now, when I run that, we notice a few things. One, we notice that we have a new object created right here in our environment pane. We also notice that we see some information about the columns that were recorded. What do you notice about the text that appears in green, red, or blue here? You might see that there's kind of this leading 4 characters of COL underscore that probably refers to the column. And then you see that it's calling out a double, a character, and a date. And these are all different types of formats for data inside of R. A character is raw text. A date is self-explanatory. It's just a date. And a double is a type of numeric format. Now you'll notice that the date actually has this additional format specified. If we wanted to, we could specify a specific date format, meaning, sometimes dates are represented like this. We might, represent the date of this recording as 3/15/2021. That's an okay way to represent a date. Most machines prefer dates in this format, and so this is the format that I'll be using during our time together. It's also the format that the data was encoded with, and that is the year dash the month dash the day. Machines like this because if I sort something by this, I'll get a chronologically sorted list after the fact. If I do it the other way, there might be some confusion. Does 1/0, the 10th month, come before the 2nd month? Not really sequentially, but sometimes that might be what a computer or a machine thinks. So we'll dig into that a little bit, but you notice right off the bat that we get some information about these different column types. You'll notice that we have this new object up here as well. You'll also notice that this object's a little bit different. We see some things about it. If you recall in our previous lecture, when we had a vector stored, we would actually see the values of that vector, particularly if it was a short vector. In this case, we're given a summary. We're told how many observations there are, in this case 10,000, and we're told how many variables there are. This is basically defining the dimensions of our table. It's saying it is 10,000 rows long and 10 columns or 10 variables wide. Now, if we want to do a little bit more and inspect this data, we can do a few things. Now, the first thing we can do is actually click this little arrow, and we notice that we get a little bit more information in here. We see a repeat of the column typing here. We also see the names of the different columns, and that can be helpful. But with 10,000 observations, there's way too much information to display in this little pane. So our studio presents a really, really convenient way to view data or to view our objects. And to do that, we're just going to click on this name, and you'll notice that it opened up a new tab in our top left-hand pane, and that tab looks pretty much like a spreadsheet. You'll also notice, if you're looking closely for those of you who have eagle eyes, that there's a way to do this via code, and this might look familiar to you from that import dialog box we were working with previously. You can do this via code if you want to, and that's with the view command. But because we're scripting automation, there's not a whole lot of value to us in terms of scripting in a command to display our data. Now, if we wanted to, we could start to look around in this. You'll notice that it's a pretty big table, but it should be very familiar to you as a spreadsheet. We can, click on one of these columns and we'll actually sort the whole table by it. This is where that date typing that I mentioned comes in really handy. You'll also notice that there's this filter button where we can actually start to filter things based off of particular values. So if I only wanted to see sutures, I could, run this filter, and now all of the rows that had needle included in them have been filtered away from this data table. And that can be helpful if you're just doing some ad hoc exploration. I don't think there's anything wrong with using any of those features. Will use those from time to time. Sometimes I'll also take a look at my raw data in a CSV file if I'm doing analysis of a CSV. When you get into more sophisticated analysis, a lot of what you're going to be doing is actually pulling information from a database. So it's a lot harder to just inspect the raw file. That's why this file viewer is so powerful. But I digress. There's lots of different options that you can explore. Now, one thing that is particularly helpful, if you're like me and you enjoy using more than one screen in your workflow, you can actually click on this little pop-out button that says Show in New Window. And when I click on that, it's going to recreate that same object in a new viewer. And you'll notice that this one is actually a free-floating window. So if I want to see just my data full screen, I can do that. If I want to set my data up on a different screen, I can pull it off to the side and have it on my secondary screen, no problem. And you're not actually limited to doing that with objects. You can do that with a script as well. So if I wanted to, I could click this same pop-out button, or I could even just grab this particular folder. You can actually navigate between the two panes that way by grabbing them and treating them almost like a web browser tab. If I wanted to see my code popped out, I could do that as well. And sometimes that's helpful if you have maybe a script that you're referencing, and then you have the script that you're actively working with right here. So lots of options there, and you can kind of do those however you like. You can also just explore things in the actual RMD file as well. So now that you're getting better acquainted with the data, we can actually take a quick look inside. We see that there's a couple different columns. There's a record key that appears to just be a sequential numbering of the columns that is unique, so not really much value add there. We see the product family. It appears that there's needle and suture as different product families. We have a part number, a product description, a work order number, the number of units that were scrapped, the number of total units inside of a given work order, and what the scrap code for that unit was. So if we look at this, we see that we have a needle, one needle that was delaminated for this work order. And we might have that same work order repeated, like here, for instance, we see this work order that ends in SLI is repeated a couple times. So we can sort of learn that work order, we can have many different scrap codes inside of a work order here. And then we notice that we have some date information associated with us. Now, if we're trying to really understand our data, looking at it directly and manually is good practice, but it's really hard for a human being to analyze the entirety of a data set. For instance, if I asked you how many product families there were, you might have a hard time answering that question without scrolling through all 10,000 rows of data. And that's not a very effective way to go about answering those types of questions. So we're going to build towards inspecting and tidying up our data a little bit, and then we'll transition into the actual analysis. Depending on how long this video runs, we may actually cut it at the end of the data tidying section and break off the actual analysis into the next section here. So we'll see how that goes. But coming back to our script, I actually want to teach you a couple commands that can help you understand things about your data. So I'm going to start, again, using that same keyboard shortcut, Control, Alt, and I. It's going to open up a code chunk for me, and I'm going to use a command called glimpse. And glimpse is a really nice command when you're first bringing in some data, because it puts you in a position to explore that data at a glimpse, hence its name. So you'll notice that I sort of started by typing out glimpse. RStudio was offering some completion for me to make things a little bit easier. And then I sort of inserted these two parentheses. Again, this should be very familiar to anybody who's used equations or formulas in Excel. And as what we call an argument, or as the object that I'm going to hand to this function, I'm going to hand my data frame, and it's the defect.df data frame. I'm going to run that, and you'll notice that we get some output generated right here. This is actually a summary of the information that we had already gleaned right here. And it's absolutely fine if you want to look in this particular top right-hand pane to explore, but sometimes it can be really helpful to put some checks into your script that print out information, so that if I'm running this script and I'm creating an RMD/HTML report, that this information actually gets captured and passed forward to the end user. So you'll notice that in between these dual brackets, we have some quick type codes. In what ways are they similar to the column types that we were looking at above? You might notice that they appear to be shortened forms of the exact same information. So record key is a double, that means it's a numeric type. For product family, we see that it's a CHR, that's a character type, and then we have these two dates down below. Now that function is really powerful because it gives us a really quick way to look at the structure of our data. Now sometimes, like what we were doing by visually inspecting the data, we actually want to see summaries of the data themselves rather than a summary of the data structure. And so to do that, we're going to use a slightly different function called summary, and we are going to pass as the argument that exact same defect data frame. So I'm going to type out defect. You notice RStudio is recommending a completion to me. I can either hit tab to accept that completion or click on the selected completion from that little drop-down menu. And I'm going to run this, and we're going to get something a little bit different. Now, those of you who have done any kind of data analysis before might be familiar with number summaries. Typically, they refer to this as a 5-number summary, and it is essentially just a representation for any kind of numeric data type of the minimum value, the maximum value, a summary value of the middle of the data. Sometimes it can be the median, sometimes it can be the mean. And then we get, the first quartile and the third quartile. If we think about the median, which is the value that we would get if we were to line up every single value in numerical order from start to finish and then grab the middle value, the first and third quartile are the exact same thing, but it is the value that would represent 25% of our data. So if we had 100 values, we'd go to value 25 and grab it. And for the third quartile, it would be the 75th percentile of our data. We'd go and grab that value. Now you'll notice that there's not a whole lot of value added in this record key section. And that's because that record key is literally just an incremental number that counts from 1 all the way up to 10,000. What do you notice though when you look at the dates? We do get some new information here, and that is that all of the information in this data set was captured on a particular time window. And that time window started on February 1st and ended on February 28th. And we know that there's not any noise in this data from this perspective. We also notice that every single unit's row represents a single unit scrapped. We know that because our minimum and our maximum values are both 1. That's another way of saying every value in the table is a 1. And we see that same thing repeated here with the total units. That means that we have a standard work order size of 6,250 units. Now, what do you notice about our character summaries? Is there any helpful information contained there? When I look at that, I don't actually see anything that's particularly helpful. And that's because right now, R is treating those text fields. Now, let's click over here and look at an example of one, product family. It's treating this text as just unstructured text. It doesn't know anything about it. So it can tell me that there are 10,000 values. It can tell me that the type or class is a character. And if we want to dig a little bit deeper, we need to do a few things. So let's talk a little bit about how we can start to select sub-items within a bigger item, like a list. Now you'll notice that when I called summary on defect data frame, I got back a summary of every single column. There's another way to do this, but to select a specific column. Now, one way to do that would be to type in that defect data frame and then use the $ to type in the column name. So the $ sort of specifies that we are going to look for one of the items that is contained within defect.df. So let's go ahead and look at let's look at scrap code. So if I run this, I get the exact same information that I had up here, but I'm specifying that I'm only interested in that column's values. Now, another way to do this is to, instead of calling something by name, we can actually call something by its index. That is to say, its location within a list. So if I open up defect.df, I notice that my first item is called record key, my second item is called product family, third, fourth, fifth, sixth, seventh, and eighth item is scrap code. So I can actually call defect.df, and then I'm going to use square brackets, and these are located just to the right of the P key on your keyboard, to open up an index selector, and I'm going to put an 8 in there. And you'll observe that it is going to do the exact same thing as above. The only difference is that it actually tells us what the name of the column is, because it assumes that we don't know that information, which is actually quite helpful. So this is an index selector, and it's important to note that different programming languages use different starting points for their index. The most common programming languages in data analysis tend to be Python and R, and unfortunately they actually use a different starting value for their index. So R starts with 1, meaning if I want to select record key, I would actually type in 1. We can do that here really quickly, and you'll see that that's going to grab a record key. Python, however, starts from 0 because computers start counting from 0, and so they're being a little bit more true to their computer science roots. Whereas R, I'm not a historian in R, but R is in many ways a tool built for statisticians and data analysts, not necessarily computer scientists. So that's a particular difference. It's not terribly important if you're only learning one of the languages, but if you end up learning both languages, that might be something that you want to watch out for. So coming down to this next section, let's actually take this character and convert it into a different type that is going to be a little bit more meaningful to us. So I told you how we can select a column. So I'm going to select that same column, and I actually do prefer to select things by name, because if I do it by index and the next time I run this report, the columns are in a different order, I might actually end up breaking my code, and I want to avoid that if at all possible. So I'm going to specify that column again by name. I'm then going to use the assignment operator. We reviewed this last time. That's Alt and the hyphen key to assign to that column a new value. And all I'm going to do by assigning that value is call a slightly different version of the scrap code. So if I were to do this right now, nothing would change. I would be taking the scrap code column and overriding it with the scrap code column. That effectively is no change at all. But there's a new function we can use called asFactor that is going to take all of the values that are contained in this column and convert them into what's called a factor. Let's actually take a quick look at what the difference is in that summary. So I'm just going to run this first, and then I'm going to create a new line under it, and I'm actually going to call the summary function of scrap code again. And I'd like you to tell me, or rather think, about what's different between these two outputs. What do you think the asFactor function does? If we were to come back to our raw data and start to look at the scrap code, you can see that there's all these different scrap code types. When we pass this column to the asFactor function, it is counting the number of times that a given value occurs and coding it as a type. So instead of just saying, I've got some text, this is saying, I have 1,094 occurrences of the delaminated text, or 1,885 occurrences of the text crit underscore upper limit underscore failure. So this is a failure of a critical value because it has exceeded its upper limit. This is much more helpful information. And it really puts us in a position to understand more intuitively and more comprehensively what's happening in our data. Now, I mentioned that we want to do things in a programmatic way. We could go back and perform this operation manually for each and every character column, but if those columns change their names or if different things happen, we would then have to come back in and manually enter our script. So I know that we haven't talked a lot about iteration yet, so I'm just going to ask you to trust me and trust what this particular line of code is going to do. But I'm going to copy and paste some code in here that I wrote that is basically going to automatically identify which columns are character type columns, and then apply to those character columns the asFactor function. This might seem a little bit overwhelming. It's definitely okay if this isn't something that you build into your workflow right from the very beginning. But if you want to learn more about these type of operations, I would turn you to the help section for the sapply and lapply functions. You can see that I'm using both of those there. It's a little bit beyond the scope of this course, but it really is the best practice in terms of trying to perform intelligent operations on our code. So I'm just going to run this code, and you'll notice that if we looked up here, we actually saw that all of our character values changed to factors, and it's even calling out levels. Now, levels are just the number of unique values that occur in that column. So for instance, for the summary of the scrapped code, we noticed that we have 8 levels, and if we were to count these 1, 2, 3, 4, 5, 6, 7, 8, there are 8 different types of scrap codes that are captured in our data. And running this single line of code changes all of our character values into factors all by itself. So I actually don't need this previous code chunk here anymore, because this is going to take care of that for me. Now, we've done enough here that I actually want to save my workflow. So I could come up here to File and hit Save. I could also just use Control S or Command S as a shortcut there. Now, one of the things that's really valuable about the way we've written this is, let's imagine for a moment that we actually have a new data set. We get next month's data. All I would need to do is replace this file with Suture defect data, and then come here and I'm going to choose Restart R and Run All Chunks. And if you watch closely, it's going to go pretty fast, but it is going to automatically recreate our entire workflow. Environment's empty. We're now loading our library packages, and then we processed everything. And if you look closely, if we open this back up, we've already taken care of encoding those columns as factors. And we can actually get a little bit more information about this by using that same glimpse command. So I'm just going to come up here and I'm going to copy the glimpse command. I'm going to paste it down here, and then I'm going to run that code chunk. You'll notice that what was previously listed as a character has now been listed as a factor, FCT being the shorthand for factor. And if we wanted to, we could also run the summary command again and get some more information about the different kinds of character or text-based values that were in our different columns. So I'm just going to type summary, defect. I'm going to use the autocomplete feature to get defect df. And when I run this, we now see that we have 2 product families. We understand the split in terms of the defect codes. We see that we have 9 different products. You'll notice it's not displaying them all because there's too many. It's only able to report out on, I think, 6 rows of data. But if we wanted more information, we could either run the summary command on a specific column, like product, or we could come over here and look at our tab. But this is how we're already starting to not just inspect our data, but tidy it up as we go along. Now, similar to using these summary functions to look at our data, we can actually just call, and all call means is really like tell R to show us an object. We can call the defect.df object and run that, and it's going to show us a little summary of this particular object. So we can see that it prints out the first 10 rows for us automatically, and we get 4 columns. If I wanted some additional columns, I could come over here and click that little arrow and see the rest of the data set. It's basically just showing the head of the data, and then we could start to tab through it if we wanted to here. Another way to look at your data, again, maybe not the most efficient one, but definitely a possibility. Yeah, so we're in a spot where our data is actually starting to look pretty tidy already. But one thing that we might notice is that when we look at this data, we have all of our scrap codes are kind of jumbled and our work orders aren't grouped together. There's a way for us to sort this data so that it maybe follows a format that makes a little bit more sense to us. And I'm going to do that again in code because I want this sorting feature to be reproduced anytime that I rerun my script. So I'm going to kind of follow the same pattern of what we did when we applied the factor function to that column. And that is that I'm going to tell R what I want to do by using a couple of those operators. So I'm going to start by calling defect.df. This is basically just saying, hey, this is the object I'm working with. And I'm actually going to introduce a new operator to you. This operator is called a Magritte pipe. If there's any art history folks on the webinar, you might appreciate that. But a Magritte pipe is a type of operator that makes reading the code a little bit easier for us. So I mentioned that functions take arguments. All the Magritte operator does is let us pipe in this object into the first argument of any given function. Now, that might feel like foreign language to you right now, and that's totally okay. Let's explore this with a really simple example. So all a Magritte pipe is a parentheses, or pardon me, rather a percentage sign, the greater than sign, and another percentage sign. Now, you might be tired of typing that, and once again, R does make this very easy for us. We can hold down Control, Shift, and M for Magritte and get that populated right away. And I can just call any function that I want here. We've already been using the summary function, so I'm going to call that. And previously, if you remember, we were actually putting inside of the function an argument. We were telling it what object it should act upon. By using the Magritte pipe, it's a shorthand that says, hey, summary function, I want you to insert or pipe in defect.df into the first spot of your argument list. And if I run this, I'm going to get the exact same output that I did above. Now this is helpful because it's maybe a little bit easier to read, what am I working with? What am I doing? Especially if you start to string together a series of commands. So this is a really, really effective way to start to string together things and preserve the human legibility of your code. So instead of the summary function, we're actually going to use a function that comes from the tidyverse called arrange. And if we want to learn more about arrange, we can already see right off the beginning that we get a little bit of information about its preferred arguments. We see that the first argument is data. What are we piping into it with that McGritter pipe? A data frame, so we're in pretty good shape. But let's actually come over here to help, and let's look at the arrange package. It tells us that it's going to arrange rows by a column value. This is the same thing as a sort. If we look at this, it also specifies the arguments. And arguments, like I said, are just pieces of information that help the function do its job. So the first question the function asks us is, what am I going to arrange? Well, our data, in this case, defect. And then if we want to, we can offer some grouping variables. This would basically say, maybe I want to arrange dates by work order. And so what this would do is it would set the work order to the same thing, and then it would arrange the dates sequentially, and then it would start over with a new sort for the next work order. This isn't necessarily critical to what we're trying to accomplish right now. So if that feels a little bit over your head, don't stress about it. Go and spend some time reading the documentation for arrange and look up some of the examples there. Now, I kind of mentioned that there are several different arguments. So our first argument is data. The next question that it asks us is, what are the variables that you would like us to arrange things by? So very simply put, I can just type in here work order, and if I run this, you'll notice that it has arranged things in such a way that all of the work orders, all of the rows of the same work order are now grouped together. You'll notice, however, that this is an ellipsis. It's those three dots, and it asks for variables. If I wanted to, I could also include, say, the product family. If we come over here and look to the right, we see that, our first row is needle, 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 suture, but that these are all still part of the same work order. So I'm just going to add a comma. That's typically how you separate arguments in a function. And I'm going to type the next variable by which I would like it to sort. And I'm going to use the autocomplete to say product family. I'm then going to run this, and you'll notice that now the product family, needle, is all grouped together. And if I come over here, we still have work order grouped together the way we wanted to. Now that's helpful, but we might want to see all of our products grouped together as well. How would you approach this? Pretty straightforward. We're just going to add in another variable here called product, and we're then going to execute this code, and we see now that we have the product family grouped together, or rather arranged first, and then we have all of the products arranged, and we have the work orders arranged. Now, I said that a little bit out of sequence. What it's actually doing is it is ordering all of the work orders first, then it's ordering product family, and then it's ordering product data. If I looked at defect data, this is still in its original order. You can tell that by the record key right here. If I want to alter defect data, I have to do that through our assignment operator. So I'm just going to type defect data again, and then I'm going to use our assignment operator. And now if I run this code, I'm actually going to overwrite this original data frame with our sorted version. So let's run that. And now let's open this up, and you can see that it has, our record key is no longer in sequential order. We've set things up pretty differently here. But that gives us the opportunity to tidy up our data pretty well. Now, I can see that we've already run pretty long here. So the last thing that we're going to look at is we are going to look at some packages that are really helpful to us. Now, we've already loaded up the tidyverse package, but let's not even pretend, because this is exactly what we're doing, but let's pretend that we are trying to find a package that will help us with our business case. And if we pull up our business case for a quick second, we can see that we are working for a suture manufacturer, and our manufacturing director has asked us to try to identify where we should invest our team's limited resources during a quality investigation for each product. We're basically trying to determine for each individual product that we manufacture what defects are most common or are occurring most frequently. We can kind of see that we're trying to build something like this Pareto analysis chart. That might be something that you're familiar with already. So let's try to find a package that can help us do that analysis here. So I'm just going to turn to a search engine. I'm going to use Bing just because I happen to use Microsoft Edge on my work browser. And I'm going to search building Pareto charts and SPC charts. That stands for statistical process control. It's another kind of quality chart in R. And doing so, I'm presented with a few results. Now, the first thing that we notice is this looks to me to be some kind of book. I'm not really sure exactly what that is, but we see this crayon.r project link. And if you remember when we talked about packages the first time, Crayon is a pretty trustworthy source for R packages. And we can see that there is this package it's pointing us to called QI charts. It's got two main functions, the QIC and the Pareto chart. It tells us that QIC is a simple way to construct SPC charts and that it's a simple way to do Pareto charts. So this looks exactly like what we're looking for. I'm going to click on this and it is going to load up the package page. And we can start to see right within this that there's this really helpful thing called a vignette. This vignette is basically a collection of tools that help us use these different things, these different functions together. And so if we look really closely, we can see that there's this QIC function, and we can see that there's this Pareto chart function. It looks exactly like what we're looking for. So we're actually going to go ahead and we're going to install that package and load it in. So let's just do install packages, and I'm going to type in the name of this package, which if you recall was QIC charts 2. So I'm going to do that, and then I am also going to do library QIC charts 2. So I'm going to start by installing that. It's going to take a second to install. And then I'm going to load this package. Again, you don't need to worry too much about this warning. It's telling us that we can either compile packages from source or we can download them from Crayon, but we downloaded it from Crayon, so that's no problem. And we're going to load the QIC charts package. I'm going to save my script here because this is already putting us in a really good place to start our analysis. Now, if we wanted to, we could come back to this vignette and we could just run a search. I'm going to type Control F and I'm going to search Pareto and see where Pareto chart appears here. I can see right off the bat that this package contains this function. If I click a little further, I can actually see that there is this section of the vignette that details exactly how to use the Pareto chart function. And we can see the output. Now, one thing that's really important, what do you notice based off of the tools that I've equipped you with? What is the first argument for this Pareto chart function? If we look in, we can see that it is taking some sort of data value. But if we look closer, it's not just taking the whole data frame, it's taking a specific column of that data frame. They're using the $sign signifier here to say, yep, go to this data object, GTT_AE_types, and grab me the category column. And when we look at this output, we can actually see that the category column appears to be some sort of character or factored variable. It's text. All this function needs to run is text. And so we're going to do a really quick example of this, and then we'll dig into our analysis a little bit later. But we're trying to create, again, thinking back to our business case, a Pareto style analysis so that we know where to focus our improvements on for products, and we're looking at scrap codes. So now that we've called or loaded that library, let's actually just type out the Pareto chart function. We can see that it's coming from the QI charts2 package. And I am just going to feed to it in its first space, defect.df, and I want to look at the scrap code. And just exploring, let's go ahead and run this and see what we get. Now you'll notice one thing that's kind of important here. It doesn't really seem like anything's rising to the top. Think back to our problem statement. Our problem statement focused on doing this analysis by product. What we have done here is grab the scrap codes for the entire data set for the whole month. And so we're going to need to change our approach here a little bit so that we can focus in on one of our products specifically. Now, let's just go ahead and take a quick look at one of our products and identify which product we might want to look at. So I'm just going to run that summary one more time to see what products we have. And based off of what I'm seeing, let's actually grab the half-inch circle, our first one. It also happens to be a pretty high frequency issue that we're running into. So I'm going to use a couple things that we've already seen, and I'm going to start by creating a new variable that is just a copy of our previous variable or of our previous data frame. I'm going to call it needle_1_2. That's for the half-inch circle needle, and we're going to look at defects. And I'm going to use some of the stuff that you have already seen. I'm going to type in our source. I'm going to use the McGritter pipe to pass our original data set into a new function called filter. Filter is a really, really simple function. All we have to do, or all we do with it as terms of an argument, is specify the logic that we want to use for a filter. So if you've done this kind of work in Excel, this should appear very native to you. I'm just going to type product equals and the product name. I just copied that from right there. So what this does is it is going to filter our original data set only to rows where product is equal to needle-1/2-circle. And if I run this, we should get a new data set, and we notice a few things right off the bat. We've got a new object right here. There's 1,116 observations of 10 variables. That matches our summary perfectly, so we're very confident that our filter was successful. And we can even just call this same data set right here if we want to take a quick peek into it. I'm just going to type out needle. I'm going to run that, and we can see that at least from a preliminary glance, everything appears to be in order. I could also inspect my data if I wanted to, and everything appears to be in order. So that puts us in a position now where we can actually amend this previous piece of code. And I'm not stingy about copying and pasting. So I'm just going to highlight my previous code. I'm going to copy it. I'm going to paste it down here. And I'm going to make one important change. And that is that I'm going to replace defect df with our new data source that is already filtered down to a specific product. And I'm going to specify the scrap code column. And then I'm going to run that chunk of code. And we can already see that a trend exists here that was not present when we looked at the entirety of our data set together. So when we ran this function right here, we don't really see, I mean, yeah, it's true that this crit ULF is the most commonly occurring problem, but all of these are pretty similar. However, when we drill down to a very specific product, we can see that if we were to take care of these three defect types, we would effectively address 75% or so of all of the defects that this particular product is encountering. Now, that's really, really powerful, but there's one additional thing that we can do here, and that is we can actually modify this particular function if we were to, run a help search on it, or if we were to go back and look at our vignette, we can see that it is very possible to add a title. All we need to do is provide a second argument that is title equals, insert the text of the title that we want. So let's go ahead and do that. I'm just going to come up here and I am going to hit the comma to indicate that we're ready for the next argument. And then I'm going to type title You'll notice it will autocomplete for me, and I'm going to type Pareto analysis of defects for the needle -1, 2. I actually had a few typos there. Sorry about that. And then I'm going to include the date as well, which was 2020 02/01 to 2020 -02-28. And if I run this, we're actually going to get a cleaner title for us. And as kind of a bonus, you can actually also enter a few other arguments in here. We can also include something called ylab, which is just the label for the y-axis. We're going to call that frequency. And then, and you can see that I actually have introduced here a multi-line code. That's no problem at all. And we can also do an xlab, and we're going to call that one defect code. So already we now have a pretty clean analysis that adds some additional assistance to us as we are trying to make sense of this data. Now, an additional thing that we can do that's kind of particularly powerful is we can actually take this graph, and just like we were doing previously, we can assign it to an object. So I'm just going to put P, and then I'm going to insert the assignment operator using Alt and hyphen. And then if I run this, it's not actually going to print out anything yet, but it creates this object up here called P for plot. And we can see that there's quite a few different things in here. What's particularly interesting in this case is that we have data. So let's actually take a look at what happens when we take our code, and I'm just going to insert another code chunk. I'm going to call P. If you remember, that $sign is just how we select an object that's nested in a list. I'm going to run pdata. And this gives us the actual summary in numerical form of the chart that we just observed. It's going to tell us how many instances of each defect there were, in this case 447. It's also going to tell us, the P here probably stands for proportion. 40% of our defects were this. And then we notice that we also have y.cum and p.cum. That stands for cumulative. So if we take 447 and add 246 to it, we get 693. The same is true of these cumulative proportions. If we were going to do a Pareto analysis, if we wanted to be really strict on the so-called 80-20 rule, we might look for the first instance of 80% in our PQM and say, if we address everything that is above this line, including that line, we will take care of 80% of our defects. Now, I don't think that the actual 80% really matters. It's more a function of what are the core few defects that I can address, and what percentage of my overall defect proportion will I take care of. And that to me is the top 3 rows. And we know that we're getting about 75% of all of our defects by doing that. Now you might say, well, that's cool, but I still want to see my charts. There's a couple ways you can do that. One, you can just call P, and that will print the chart again because that is the default behavior. Or if we really needed to specify for some reason, we could use that same notation to dig into the plot environment. And then again, P is kind of the shorthand for plot in R. And if I run this code, I'm going to get the exact same thing. And now we've basically been able to do something pretty powerful. We've not only been able to generate a visual, but we've also been able to programmatically generate the numerical summary that we could then feed into other kinds of analysis as needed. So now the question becomes, have we answered our business case? Let's jump back to it. We were told that we needed to identify where our director should direct her team's limited resources in order to have the largest impact during their quality investigation for each product. Have we done that for each product? No. We've done that for a single product, but we've gotten acquainted with the materials and the methods necessary to generate this kind of analysis. And in our next session, we'll dig into how to recreate this same approach in a more programmatic fashion. Thanks so much for your time, and I really look forward to our next conversation.